All right. Hello, everyone. So this is the beginning of section 4.5 on page 311, equivalent forms of the equation of a quadratic function. So let's begin by looking at factoring this trinomial. And guys, at this time, I have certain expectations, and one of the expectations I have is as you look at this, you should already recognize it as a perfect square trinomial wherein the binomial, when you square it, that would give you that perfect square trinomial is x minus 5 squared. Now, if you're thinking, how did I get that? Um, this one would have a square root of plus or minus 5, but then when you double it, it could either be plus or plus 10, but or negative 10. But then, excuse me, since the middle term is negative, so I have a negative sign here. The other one, this one, is also a perfect square trinomial because this one is a square root, this one is a square root, right? X here, 9 here. All right. And then this is the result of 2 times the product of these two square roots. So really, it would be x plus 9 squared. Make sense? Okay. In each trinomial, how is the third term related to the second term? All right. The third term, okay, the third term is the square of 1/2 of the middle term is 18. What is half of that? 9. What is 9 squared? 81. There you go. Got it? Okay. Construct understanding, still the same page, but on the lower part. Match the equation in standard form with its equivalent equation in general form. Now, guys, um, some of you might think that, oh, coming from math 10, since you are used to y equals mx plus b, you might be thinking that the number at the end would always be the y-intercept, okay? This one. But then, guys, you have to be careful because when you are working with um, quadratic equations, sometimes that is not the case. So take a look at what I have for you. All right. So as you look at what um, this one, okay, would match up with in here in the second column, you have to ask yourself if you expand this binomial, all right, if you do FOIL, this negative 2 would be multiplied by itself. That would be positive 4, right? And then there's a negative in front, so it becomes negative 4. And if you are to add the 7 over here, what will you have? That will be positive 3. Therefore, it will match up with the equation in this column that would have a plus 3 at the very end, and it is this one. Okay? So, what about for the second one? You might be tempted to think that, oh, there's a negative 1 at the end, there's a negative 1 here. That is not the case. All right? So, again, ask yourself, if you were to FOIL this, x plus 2 squared, this last number multiplied by itself would be 2 squared gives you 4, and there's a negative in front that gives you negative 4. But then subtract 1 that gives you negative 5. So this one matches up with this. You good? Okay. Next. So this one, when you square 1, that would be 1 times 3. The coefficient, that would be 3. 3, and then you subtract 4, that would be negative 1, and this one matches up with this. And of course, the only other one that does not match up with anything would be this one. And if you want, we can check. Negative 2 squared times 3. Negative 2 squared is 4 times 3 is 12 plus 5 is 17, and you have your 17 here. Okay, here we go next. An equation of quadratic function in standard form, or also known as vertex form, can be expanded and written in the general form. Okay, now if you can write an, um, a vertex form into a general form, that means you should be able to write a general form into a vertex form. Okay, you go the other way. All right. If you consider this equation, x squared minus 4x plus 10, and you are to do completing the square, you will be able to rewrite this equation in this case. Okay. All right. How I do it quickly is I just ask myself, okay, so x squared minus 4x plus 10, if I want to put it in completing the square, so x squared minus 4x would have a completed square if I add 4, right? But then I actually have a plus 10. So I need another plus 6 because these two would make up the 10. So in this case, I am able to quickly come up with the completing the square method, and gives me this one. Okay. When a function has the form ax squared plus bx plus c, just be careful. Always remove the a in front of the x squared from the first two terms before you do completing the square. All right. Just so that you remember. Okay. Because a lot of times that seems to be a problem when kids forget. Okay. And that's it for this video. I'll make another one for check understanding number one. Thank you for watching. Bye.